Hi guys, this is the video to discuss the reinforcement practice for the topic 2, differentiation. For differentiation topics, we have involved the differentiation on a constant function, polynomial function, and also the quotient function. Let's look at the question 1. I have 9 questions in total. So let's look at this question. Find the derivative of f(x) equals to 7 over 3x by using the first principle. To use the first principle, we have to recall back the formula for the first principle. That is a limit when h approaches to 0. And the formula is f(x) plus h minus f(x) over h. So first of all, if given the f(x) is your 7 over 3x, then we need to find f(x) plus h first, meaning that all the x here will be substituted as x plus h. Then I will substitute the f(x) plus h and f(x) into the formula to get my f prime x. This is a limit. And f(x) plus h given is 7 over 3 x plus h, that we have found it just now, and minus f(x) and the whole thing over h. And to simplify it, if we use the substitution method, direct substitution, h equals to 0 into the formula, we will get something over 0, which will make our formula undefined. So I need to find some a h on top, so that it can cancel off with the h below here. First of all, we may equate the denominator. Equate the denominator. So we make the denominator as a 3x multiplied by x plus h. And down there over h. Up here, if we want to make this denominator to be 3x x plus h, then we know here has to be multiplied by x, and on top we need to do the same. Alright, x over x. So I have my 7x for the first term, and minus, if 3x I want to make it into 3x x plus h, meaning that I need to multiply this by x plus h. And we did the same for the numerator. So up here I have my 7 multiplied by x plus h. And before the tutorial, I've mentioned that if you have a over b over c, we can write this in the form of a over bc. So for my solution here, I need to simplify the top function, and the down here, this is a b, this is a c. They can combine together by multiply them. As long as we haven't processed the limit, we need to write down the limit. And 7x minus 7x, you got 0. Negative 7 multiplied by h, you got negative 7h over. So I will put the h together with this. And here you can see that h and the h can be cancelled off. Alright, then I have a negative 7 over 3x x plus h. Now I can directly process my limit by substituting the h equals to 0 into here. So once you start to process the limit, meaning that you don't have to write down the limit. You just write down what you substitute. Means that just now I say you substitute h as 0, so you get x plus 0. Simplify your answer. That will be negative 7 over 3x squared, because 3x multiplied by x, you get 3x. And you may check the answer by using the techniques of differentiation. So f(x) given as a 7 over 3x. Let's find out if we use a technique of differentiation. See what we'll get. Given the f(x), okay, given the f(x), is 7 over 3 3x. 7 over 3x. So this 7 over 3 as a coefficient, just write down, and you have x power of negative 1. So when we use a technique of differentiation, which are power rule, then you will bring the negative 1 over, you get negative 7 over 3. And the power of x, negative 1 minus 1, you get negative 2. Then you will have simplified it, you will have a negative 7 over 3x squared. Just check with your answer by using the first principle. And we can see that we got the same answer by using the power rule and by using the technique of, first principle. Now we proceed to the next question. Question 2. Question 2, we have a square root of 2x squared plus 5x minus 3. Find dy dx. So for this question, again, I will apply the power rule. Before differentiate, I will rewrite my question into this form. Square root means that it has a power of 1 over 2. To get the dy dx, we apply the power rule, bring the 1 over 2 over to the front, provide a bracket to put in our inner function. Our inner function is this, 2x squared plus 5x minus 3. And the outer function is something power of 1 over 2. So now actually I'm differentiating the outer function. Differentiating something power of 1 over 2, I will bring the 1 over 2 to the front. And then the bracket power is minus 1, I got negative 1 over 2. So whatever inside this bracket as an inner function, you just write down, copy it down into the bracket over here. After that, you need to multiply by differentiate the inner function. Differentiate the inner function, you got a 4x plus 5. Alright, then now you can simplify your answer. You get 4x plus 5 over 2 square root of 2x squared plus 5x minus 3. Alright, for the question 3, we have 2x multiplied by 1 over x minus 3, x squared, and then this is in the bracket square. So some of you may say that you want to apply the product rule by taking this as u, this taking as a v, but I'm not going to do that. I'm going to expand this first, and then I will multiply the 2x inside. Alright, expand it, meaning that I will write down the 2 this function in the bracket. I will write them down to represent a square, and then after that I will expand it by taking the 1 over x multiplied by 1 over x. You get 1 over x squared minus 1 over x multiplied by negative 3x squared. You got a negative 3x because the x squared and this x can be cancelled off, and you left 1x. Minus, again, you have 3x, because 3x, negative 3x squared multiplied by 1 over x, you get negative 3x. And lastly, you have a negative 3x squared multiplied by negative 3x squared, you get positive 9x power of 4. Check if we have any like term, we can combine them. 1 over x squared minus 6x plus 9x power of 4. Then the 2x can be multiplied inside. We have a 2x multiplied by 1 over x. We got a 2 over x. Because the x cancel off, one of the x cancel off. And minus 2x multiplied by negative 6x, you get 12x squared. 2x multiplied by 9x power of 4, you got a 18. 18x power of 5. So this is not yet your dy dx. This is just what you have simplify into the form that easy for you to differentiate. Now this is just your y. So now I'm going to differentiate the y with respect to x. So to differentiate this, you might know that this is in the form of 2x power of negative 1. So to differentiate it, you just write down the 2 first, and then bring negative 1 over to the front. And the power of x minus 1, you get negative 2. To differentiate the second term, you got to bring the 2 over multiplied by 12, you got a negative 24x power of 1, because the power of 2 minus 1, you got 1. And lastly, you have bring the 5 over to multiply by 18, you get a 90x power of 4. Then simplify it. Simplify the whole solution, whole answer. You got negative 2 over x squared minus 24x plus 90x power of 4. And for this question, we have part A and part B. Now we move to the part B. To define the dy/dx for this question, I need to apply the quotient rule. So take this as your u and the down function, the lower function, as your v. So as your u equals to 1 over 3x, to get your u prime, you have negative 3. If your v equals to x squared plus x minus 3, then v prime is 2x plus 1. After you have a u prime and v prime, we will proceed to dy/dx. To apply the quotient rule, you are going to copy down the v first and then differentiate the u, get your u prime. Copy the u, differentiate the v, get your v prime over v squared. Copy down the v first, you will get x squared plus x minus 3 and multiply by u prime, which is your negative 3, minus, copy down the u, 1 minus 3x, and multiply by v prime, you have your 2x plus 1. And this whole thing here over v squared. So now we can see that up there can be simplified maybe. So we need to expand first, then we check. So after you have expanded the numerator, you will get this. And simplify again. Simplify further. And simplify the numerator, you get this. 3x squared minus 2x plus 8 over x squared plus x minus 3 squared. You leave this as your final answer. Now we move to the next question. For this question, use the first principle to find dy/dx given y equals to 3 minus x squared. So I will rename the y as fx, and fx is equals to 3 minus x squared. I try to expand first so that later on it's easier for me to substitute the x plus h into the x. So this is your 3 multiplied by 3, 9. And then you have negative 3x, negative 6x plus x squared. Then now I need to find my fx plus h. In order to find the derivative by first principle, I need the fx plus h. So substitute all the x here by x plus h. I will have this. And I suggest to expand first so that later on it's easy for us to simplify. When we substitute into the formula of the first principle, here I got negative 6x minus 6h plus x squared plus 2hx plus h squared. Alright, then now if there's any like term, we can simplify. We try to simplify. So 9x, alright, and yeah, that's it. So I will stick to the formula of the first principle. F prime x equals to the limit when h approaches to 0. The formula given as a fx plus h minus fx over h. Substitute the fx plus h that we already found it, and we already expand it. You have your 9 minus 6x minus 6h plus x squared plus 2hx plus h squared minus fx. fx, which is given as a negative 9 minus 6x plus x squared. Alright, then this one is all of them over h. So for this limit, we cannot just substitute the h equals to 0. Because it will make our formula to be undefined. See, you divide something by 0. So we need to find a h from the numerator so that we can cancel off with the h at the denominator here. So let's simplify this first. 9 minus 9 cancel off. And negative 6x plus 6x cancel off. x squared minus x squared cancel off. So what you left here is only the negative 6h plus 2hx plus h squared. So let's factor out the h. You got your negative 6 plus 2x, alright, and plus h over h. So now you can see that there is a h on top, so that you can cancel off with the h below. You left a negative 6 plus 2x plus h. So now we can use a direct substitution method, that is substitute the h equals to 0 into the h over here. We got a negative 6 plus 2x. Alright, so this is our answer. And we always can check our answer with the technique of differentiation. If we have this function, we want to use the technique of differentiation to find the dy dx. Let's see what do we get. Alright, we can apply the power rule. 2, you move to the front, fix this as your inner function, and the power is minus 1, you got 1. Inner function, we just copy it down, that is a 3 minus x, and then you need to differentiate the inner function, you get negative 1. Okay, so we have a 2, 3 minus x, negative. Then after that, we have a negative 6 plus 2x. Alright, so what we get with the technique of differentiation, which is the power rule, is the same answer as what we get from the first principle. So we can be sure that this answer is correct. For the question 5, differentiate this quotient function with respect to x. Now I have to use a quotient rule to differentiate to find the dy dx of this function. So quotient rule, given the quotient rule, the formula is bu prime minus uv prime over v squared. First of all, I will define my u as my 3x plus 1 and get your u prime first, that is 3. And v is x minus 2. So v prime will be 1. Substitute into the quotient formula, quotient rules. Formula, you have your x minus 2, that is your v, multiplied by u prime given as 3, and u will be 3x plus 1. V prime is 1, and the whole thing over the v squared, which is x minus 2 squared. Numerator, we can see that we can expand and simplify, that we have 3x minus 6 minus 3x minus 1 over x minus 2 squared. Then we have to simplify 3x minus 3x, you got 0, and you left a negative 7 for the numerator, and down here you have your x minus 2 squared. There's your answer for question 5. For the question 6, use the first principle to find dy dx for this function. So again, we need to use first principle. Firstly, we rename the function to be fx. I got my 4x squared minus 2, and I will expand it first. I got my 4x squared minus 8, so that easier for me to substitute x plus h when I want to find the fx plus h. So what does it mean by fx plus h? Fx plus h means that I will substitute this x with the x plus h. Then I will get x plus h squared, 4x plus h squared minus 8, because this x has been substituted as x plus h. Then I will expand first, x squared plus 2hx plus h squared minus 8, and multiply the 4 inside, you get 4x squared plus 8hx plus 4h squared minus 8. And then we want to find the first derivative. We need to use the formula of the first principle. This is a formula of the first principle, fx plus h minus fx over h. This is a limit when h approaches to 0. So substitute the fx plus h inside, get your limit. You need to copy down the limit because now you are actually processing the limit. Then substitute this, 4x squared plus 8hx plus 4h squared minus 8. This is your fx plus h minus fx. Fx is a 4x squared, because minus you got positive 8, and over h. So here, if you want to find the limit, we cannot direct substitute the h equals to 0 because the h equals to 0 will make this function undefined, yeah, because the something over 0 will be undefined. So now we need to simplify the numerator. See what we can do. 4x squared, 4x squared minus 4x squared can be cancelled off, and negative 8 plus 8 cancel off. And you left 8hx plus 4h squared, where these two terms all contain, both of them containing the h. So I can take out the h, take out the 4 if you want. Then I have a 2x for the first term, and the second term I have a 2h over h. So now you can see that on top we have a h, and down here we also have a h. So we can cancel off the both h. Then now I can substitute h equals to 0 inside. Here you will get 4 multiplied by 2x plus 0. That will be my 8x. This is the answer. And you always can check your answer by using first principle. So we are actually worried that maybe we'll do something wrong. So you always can check the answer by using the first technique of differentiation. I copy down the x first, that is my y, and then use the rules of power rules of differentiation. We try to differentiate whether you see if we get the same answer by using the first principle. 4 is a coefficient, just copy down, and you have a 2x. Differentiate negative 2, you get 0. So you got the 8x after you have used the power rule. You see that you have a dy dx equals to 8x, which is the same answer as you got it by the first principle. Followed by question 7. Find the value of dy dx when x equals to 1 if y is this function. So you need to find the dy dx, and then you need to substitute x equals to 1 into your answer of dy dx. Evaluate what is the value of dy dx when x equals to 1. Here I would like to find the dy dx first. First of all, let us expand first. Expand this because square, we expand. Two x multiplied by 2x, you got 4x squared. And 2x multiplied by negative 1 over x squared, you got a 2 over x. And negative 2 over x as well, because negative 1 over x squared multiplied by 2x, you also will get negative 2 over x. Plus negative 1 over x squared multiplied by negative 1 over x squared, you got a positive 1 over x power of 4. Then multiply 3x inside, you got the first term, you got the 12x cubed, and you have a negative 6 as well for the third term, because these two are the like terms, and plus with the 3 over x cubed. Okay, 3x multiplied by 1 over x power of 4 can get a 3 over x cubed. So simplify, you have a negative 12 plus 3 over x cubed, and 3 over x cubed, maybe we can rewrite it in this form, 3x power of negative 3. Easier for us to find the dy dx. What is the dy dx? dy dx is 36. Alright, bring the 3, multiply by 12, that is 6. 36 x power of 2. And differentiate the negative 12, you get 0. Differentiate 3x power of negative 3, you get negative 9x. The power minus 1, you get negative 4. Okay, so you can rewrite this in this form. It's okay if you want. Then after that, recall back the question. We have we need to find the value of a dy dx when the x equals to 1, meaning that we need to find the gradient of this curve, of the curve of the y, and at the x equals to 1. So we can actually write down in this form, this is a dy dx when x equals to 1. We can substitute this 1 into our x, and try to find out the value that this is 36 minus 9, which is 27. For this question, we have a part B. Same thing, I will find dy dx and then substitute x equals to 1 into my dy dx. Here, this is the quotient form. It's a function of quotient form. I will let this become the u, this become the v, because I'm going to apply the quotient rule. Let u become the 3 minus x, then u prime you will get negative 1. If the v equals to x squared plus 2x minus 1, then v prime is the 2x plus 2. Then I would find the dy dx by applying the quotient rule, which copy the v first and then multiply by u prime minus uv prime over v squared. Copy the v first, that is your x squared plus 2x minus 1, which is your v, this is your v, and u prime is negative 1 minus uv prime. U will be 3 minus x, and v prime is your 2x plus 2. And the whole thing over v square means that this is v square. Okay, so what we can see is the numerator can be simplified. We have a negative x squared minus 2x plus 1. Okay, I multiply the negative 1 inside. And expand these two, you have 6x. 3 multiplied by 2, you get a positive 6. And negative 2x squared, negative 2x over x squared plus 2x minus 1 squared. After that, we combine the like term. Okay, combine the like term. Before I combine, I settle the sign first, which here I will get a 6x minus 2x, I got 4x, negative 4x. And negative 6, negative multiplied by negative, you got positive 2x squared. Over v squared. Continue, simplify. You have 2x squared minus x squared, you got x squared. Like term, negative 2x minus 4x, you got negative 6x. And 1 minus 6, you got negative 5. X squared plus 2x minus 1 squared. Okay, then after that we can see that on top we can actually simplify it. 5 1 negative negative, yes, cannot be factorized. Cannot be factorized means that we'll leave our answer like that, and we are going to evaluate the value of dy dx. This is a dy dx, this is a dy dx. But the question is asking for the dy dx when the x equals to 1. Substitute x equals to 1 into our answer of dy dx. I got 1 squared minus 6 multiplied by 1 minus 5 over 1 squared plus 2 minus 1 squared. So you have a negative 11 plus 1, negative 10 over 1 but 2, 4. Okay, so the answer is 5 over 2, negative 5 over 2. Question number 8. I will write the question function in the form of power, means that if this is a coefficient and something over x power of 4, I will write it into the form of x power of negative 4, and 8x power of 3 over 4. This is just nice. And the square root of 2x, I also will change into the x power of 1 over 2. Then I'll start to differentiate it, finding the f prime x. This is a coefficient, 5 over 4, so just write it down. And how do you differentiate x power of negative 4? You just bring the negative 4 over to the front. And the power of negative 4 minus 1, you get negative 5. Then again, the negative 8 is a coefficient, so just write it down. And to differentiate x power of 3 over 4, bring the 3 over 4 to the front, and the power of 3 over 4 minus 1, I got my negative 1 over 4. Okay, then again for the third term, I have my 2 coefficient 2, copy it down, and then you bring the 1 over 2 to the front, and the power of 1 over 2 minus 1, you get negative 1 over 2. Then after that, we can simplify. We can simplify what we have. Yes. Then write down your answer. The first term, you have your negative 5 over x power of 5. Okay, then second term, you have a negative 6 over x power of 1 over 4. And third term, you have a 1 over square root of x. Okay, so this is the answer. And this is a question 8b, part B. The same thing, you need to get a f prime x. So for this question, I would take out the 1 over x first. Then I will try to expand 3x plus 4 multiplied by 2x cubed plus 7. So expand what is inside here for these two factors first. I got my 6x power of 4 plus 21x plus 8x cubed and plus 28. And then 1 over x I can multiply inside. I do it step by step. I have my 6x power of 3 and plus 21. Plus after that we have 8x squared and plus 28x power of negative 1. So once you have simplified the fx, this is your fx, you can get your f prime x. F prime x means that you are going to differentiate term by term. Differentiate the first term, you got 18x squared. Differentiate 21, you get 0. And differentiate 8x squared, you get 16x. And differentiate 28x power of negative 1, you got negative 28x power of negative 2. And you can actually rewrite the third term into this form, 28 over x squared. This is 16. Alright, so this is the answer for the 8b. And this is the question 9, which is the last question for this reinforcement practice. And because question 9 asks us to differentiate the following with respect to x, where we have part A and part B. For the part A, I will rewrite the function into this form, easy for me to differentiate. And the second term that is fine to differentiate. And the third term change to the power of 1 over 2. Then now finding the f prime x. The 2 over 3, you copy it down. Bring the negative 3 to the front. And the power of negative 3 minus 1, you get negative 4. Coefficient again, copy down and bring the 2 over 3 to the front. Power of 2 over 3 minus 1, you will have a negative 1 over 3 minus 1 over 2x power of negative 1 over 2. So basically you have done the differentiation. Now just need to simplify. 3 negative 3, this one can be cancelled off. So we have a negative 2 over x power of 4. And this is 2 over cube root of x. The last term is 1 over 2 square root of x. Alright, so this is the answer. And for the part B, you can either choose to take out the 1 over x first and then you expand, or you can use the product rule. It's up to you. So but I will choose to expand. I think the process will be more easier, simpler. Take out the 1 over x. Then I will expand this first. You got 2x cubed plus 2x plus x squared plus 1. Then multiply 1 over x inside. You have 2x squared plus 2 plus x plus 1 over x. Then 1 over x is actually x power of negative 1. Then we try, okay, so all the term is ready for us to differentiate. Get your f prime x. So this is your 4x. Differentiate 2, you got 0. Differentiate x, you get 1. And differentiate the x power of negative 1, you got negative x power of negative 2. Simplify, you will have this answer. Alright, So we have done on all 9 questions in our reinforcement practice for the topic differentiation. So hope that it helps you in doing the revision, and thank you for watching my video. Thank you.